In this video, we'll discuss there are the ways to evaluate a limit, because evaluating a limit is a very, very important task in calculus, right? No matter you are dealing with derivatives, integrations, or special limit, it has many applications. So let's try to discuss our ways to evaluate a given limit. Let's start from some easy the evaluation of limit with starting with some easy functions, right? So let's say this: if your function, let's say if your function is a constant, right? So your function is always constant, which means your function is always the same number, right? Either 1 or 2. That's a horizontal line, doesn't change at all, right? So suppose your function value is always c. You fix a point, which is a, arbitrary a here. This is c here, right? Let's try to sketch a graph and make our understanding easier, right? So this is our x, y plane here. This is our y here. This is our c here. So such a function will be a constant no matter what is c, right? It's always constant. So as long as x goes to anywhere, the function value doesn't change, right? So this for sure is equal to c. That doesn't change at all. Now, the second easiest observation here is as the constant function, not constant, identity function. As x goes to a here, then x goes to where, right? This for sure goes to a, right? Because x goes to a, your function is the same as x, for sure your function also goes to a, right? Now let's introduce a few general laws we can follow to evaluate limit. For example, just some elementary operations or functions, right? Product, quotient, plus or minus, right? Easy one. And let's suppose this, right? C here is always a constant. As always, C here is a constant. And depends on the situation, might be 0 or may not be, right? So let's suppose, right, give some assumptions. Suppose you know something. Suppose as x goes to a, f of x, and as x goes to a here, g of x exist as a finite number. So the limit doesn't, this laws we are discussing doesn't apply to the limit which is infinity, right? So infinite limit doesn't apply to this laws. Limit a number, right? Sometimes for sure the first law we have here is what's the limit of the sum, right? F of x plus g of x. You generate a new function by taking a sum. You know the limit of each function. What's the limit of the sum of this function? Clearly, right? It should be goes to the sum of the limit. So this will be same as x goes to a, f of x plus as x goes to a, g of x. Imagine that there should be true, right? And let's see the second law we have here is you can do multiplication. So as x goes to a here, c is a constant times f of x, right? And it's for sure, right? C here multiply that number function. It should go to the limit times c, right? It should be same as c times as x goes to a here, f of x. And third one, quotient, no, product. Okay, second one is a constant multiple. And third one is the product of two functions, f of x times g of x. So this will be same as x goes to a, f of x times as x goes to a, g of x. You can split it only if both limits exist. If one of the factor does not have limit, so this rule fails. You cannot do that. There are many examples. The limit of product is not equal to the product of limits because one of the factor does not have a limit. Number 4 here, quotient, as x goes to a here, f of x over g of x, right? And so this is same as the quotient of limit. And for sure, in this case, we can we need to assume that the denominator is not 0, right? When what happens as x goes to a, g of x is not 0. So this is a general laws we follow as long as the limit of term or factors are finite numbers, right? If you have infinite or 0, 0 works, right? If you have infinite or negative infinite, that doesn't work, right? And follow from our 2 very easy observations, right? And all of our for all our laws here, right? Now you can see that. Let's write down some easy fact, right? So if you have if you want to calculate x goes to a x squared, because x squared is x times x. Both factor goes to a, right? So this for sure is same as x goes to ax times as x goes to ax, because we know both factor has the limits of both factor are finite number, which are a, so this is equal to a squared, right? So in general, as x goes to a, x to n here, this is always a to n. So power function, we know how to calculate the limit, right, for any power n here. So here we have our first method to evaluate a limit, right? So our first method to evaluate a limit, which is called direct substitution property. Substitution property. You can just plug in a, replace x by a, and then try to evaluate that number. That's your limit. So okay, if you have f here is if f here is a polynomial. What's polynomial? Polynomial is basically sum or difference, several sum or difference of power functions, and sometimes multiplied by number. And if you want to write down general formula, you can write this as C1. Okay, let's say Cn x to n plus Cn minus 1 x and minus 1. C, all the c's are constant, right? All the way to C1x plus C0. So that's a typical representation of polynomials, right? All rationals. Rational is basically rational function. Is basically the quotient of polynomials. So this is PQ over QQ. Where our PQ, QQ are both polynomials. So polynomials, right? So in this case, we know the limit is good, right? And what happens is a here is in the domain of f, right? We know that you have a function number in your domain, then the limit as x goes to a, f is basically f of x here, is basically f of a here, right? As long as f of a is well defined, all you need to do is plug a into the function, you get the limit of this function at a, right? So let's see one example, right? One quick example here. Example. Split it. So let's see this, right? As x goes to -2, x cubed plus 2x squared minus 1, 5 minus 3x, right? You can see that the domain of the inner function here is all the x cannot be what, 5/3, right? If you have x is 5/3, denominator 0, which means that's not good, right? So the domain of this function is from -infinity to 5/3, and from 5/3 to positive infinity, right? Now, how do we do this? This is a clearly standard rational function, right? Polynomial over polynomial. So numerator is a polynomial, denominator is also a polynomial. So polynomial over polynomial. What do you want to do here is you can apply our quotient, this formulas here, right? Plug in a eventually, and so this answer should be -2 to the power 3 plus 2 times -2 to the power 2, then -1 over 5 minus 3 times -2, right? So this is the limit of such a function. You can simplify that if you want, and but this is good, right? And this should be -1/11, right? So that's the final answer for this. So first method is very straightforward. All you want to do is plug in the number a to get the limit whenever your function is a polynomial or rational, and a here is in the domain. If a is not in the domain, you cannot plug in for sure because f of a is not defined.